So here is the first problem from the calculator section. As you remember, multiple choice has two sections. One section is non-calculator based, so you're not allowed to use calculator in that section. And the second section is calculator based, where calculator is allowed. There may be a few problems where it's actually required, but most of them it's allowed. So if we need to use it, we can use it. Okay, so this is the first problem from the calculator-based section. So we can take a minute to read it, and then let's start discussing what your thoughts are and how you would approach this problem. If you're capable of writing on Jamboard, please feel free to write. If you only can watch, if you don't have touchpad or iPad or any other gadget that allows you to write on it, then just say, and I will try to write your thoughts on the Jamboard. Okay.
You see what I'm writing?
F of 1, F at 1.
F of 1 is equal to -9 according to the first line of the definition function f. And after that, it has to coincide with the limit value when x approaches 1 from the right that we can get from the second line. And so we just need to equate -1 minus 2k to -9. And frankly speaking, I don't understand why the calculator is needed in this task at all.
No, as I said, calculator section does not mean that every problem requires calculator. It means that calculator is allowed. So some problems require it. Some problems you may use it. For some problems, you don't have to use it. So it doesn't mean that in every single problem we will have to use calculator. Okay. But we also may consider, and it's a very interesting question, how can we use calculator if we want? Okay, so let's first solve the problem as we think it should be solved, and then we can discuss whether the use of calculator makes sense here or does not. So yes, f at 1 equals -9, right? So -1 minus 2k, right? Which is the so the function for the function to be continuous, right? Does everyone agree with what's written? Any other thoughts?
Yeah, I agree.
Yeah, and we also remember this is a multiple choice section. So for multiple choice section, technically we only need the answer. That's why writing out the solution is not so crucial. Because if it were, for example, an open-end question, right, what's written on the board right now definitely will not be sufficient to solve the problem to get full credit, because you will have to employ limits. You will have to show that the limit from the left has to be equal to the limit from the right, and the limit from the left is equal to this, the limit from the right is equal to this. But for a multiple choice question where we just need to do quick notes to solve the problem, get the answer, that's more than enough, okay? And we got the answer. The answer is 4. Does everyone agree with that?
Yep.
Okay, good. So the answer is C, 4. Okay, question. Does anyone see a way to use calculator here? Because again, I want us to be like open-minded and play the role of the students. Sometimes they use calculators where it's not necessary. So what do you think? Is there a room for using calculator here at all.
Well, I see a possibility to draw graphs of those functions
Uh-huh.
and see that they intersect at x equals 1.
But I had such an idea, but the matter is that the second row of the formula, it has a parameter in it, and the value of the parameter is unknown, and it means that you have to kind of guess the value, which is not quite useful.
Right. So in this case, something like GeoGebra or Desmos could be quite helpful because you can use a slider to create from the parameter, and then you can basically move the slider back and forth to see when the graph will actually, connect to the other piece of the graph, right? So in this case, technology would be useful. Calculator does not allow us to do that. So in calculator, we would have to basically type every new function with every new value of k, and we can find the approximation. The intersection. But I want us to use this chance, and let me try to share the screen. I hope it's going to work. The window, yes, here we go. Does everyone see the calculator that I'm sharing? The screen that I'm sharing, does everyone see it?
Yeah.
Okay, so let's quickly see, since we mentioned graphing functions and finding intersection, how we would do it on calculator so that you just know it as, as a skill. So, for example, here the first function is negative 2x squared minus 7. And x is just less than or equal to 1. So we can go to y equals, okay, and we can say negative 2x squared. And as I type, I would like to present several interesting features. So first of all, minus, you have to be very careful. There are two minuses here. One, as you see, it's a minus on the gray button, and there's a minus in the parentheses in the white button. So there's a big difference between them, because if I, for example, use the gray minus here, I, for example, want to graph it, the calculator will give me an error. So why does it give me an error? Because this minus is not for negative. This minus is for subtraction. And the minus in the parentheses on the white key is actually a minus for the negative. Then there's a shortcut for squaring. You can do x squared as a regular power. So for example, I could have said x, so I can delete this. I can say x to the power of 2. But that's a general way to do it with any power. Whereas the shortcut here is the key x squared. So if I want to square anything, once I type it, I can just click that key and I have squaring right away. Another thing to remember, that once you got into AppleScript, you have to click the right arrow to get back to the regular line. Otherwise, you will continue typing in the AppleScript format. So now we have to do +7. Now we have to do +7. Okay, and we can actually, if we want something fancy, we can actually graph a restricted domain. So we can either do the entire graph. Okay, and that's how it will look like.
Yeah, but by the way, in our task, in our problem, we have -7.
-7, sure. I don't know why I put plus. So we can easily correct it. That was my mistake. So now we use actually the other minus. That's a good example of using both minuses in the same problem. And here is now the graph. that we have. Okay, that's good. And right away, that's a good problem because we can look at many calculated features at once. If we're not happy that our graph is too low, we can go to Window, and as you see, it allows us to change parameters. It allows us to change the maximum and minimum values of X on the screen. X scale, that means how much each tick on the screen will be. By default, it's 1. We can change the Y. Okay, we can change resolution, delta X, but that's more for more complicated problems. So we want to change probably the Y scale a little bit. We don't need it from -10 to 10. We would be happy, for example, from negative, I don't know, 20 to 0. And we'll see if it actually works for us. So now our graph will look much better because it's more like more centered on the screen. Okay. If we want the table of values, we can click second graph, and that will give us a table of values. Okay, and the table we can also tune the way we want. We go to second window. That allows us to tune the table. So we can say where to start the table. Right now it starts at 0. We can start any number. And delta table is a step. If, for example, I want my step to be not 1, but 0.5, and if you now go to second table, you will see that the values go in 0.5 increments of the X variable. So these are the basic things that are, that our calculator is capable of doing. The thing I wanted to show is how to be a little bit more fancy. Just 1 second. I don't know why it's not working. Just 1 moment, please. I'll try to fix it.
And by the way, on this calculator there is no backspace, yes? So if you want to clear the last digit, you need to go to it, and delete it.
Sorry, what did you say? I was trying to fix it. I didn't hear.
So there is no backspace on this calculator, so you need to go exactly to the digit that you want to delete and hit delete, yeah?
No, you can technically, yes, you can, you need to go with the right arrow. Yes, you need to go with the right arrow. For example, if you want to, I don't know, change anything with the sign, you need to go to here. You need to go to this minus, and once it clicks on it, you can change it. Okay, you can also use delete as your kind of so that deletes the number and put it back something else. And there's also a very interesting feature that allows you to insert something if you want. So for example, if you go here and you go second delete insert, you can now make it 17. Okay, and if you don't need 17, we just delete it. Okay, so what I want to show now Let me see if I am able to do it correctly. Okay, if I open the parentheses, and our restriction in this problem is x should be less than or equal to 1, right? So x, then I go to math, okay, and oops, sorry. I meant second math. I meant second math, and the test gives me all these options. I can either go down to it or just click 6. Okay, and let's say go to 1, close the parentheses. Let's hit graph. As you see now, it will only graph part of the function. What happened? Not sure what happened. Why did it do it this strange way?
Maybe the code is subtracted only for x less or equal than 1?
Yes, that's what I want, but I don't know where the second piece came from, to be honest. Just give me 1 second. I'm not sure.
The second piece is without subtraction of 7.
Yeah, but why it appeared there? That's not clear to me.
Kind of looks like it makes
Here we go.
the
Here we go.
normal-
Yes. Here we go. I forgot the backslash. Sorry. I forgot the backslash. So you have to put the backslash on the backslash, the regular slash, open the parentheses, write your restriction on domain, close the parentheses, and then when you graph, it only graphs the piece that you want. So as you see now, we actually see the piece of the graph that we need for this problem, not the entire graph, which is very, very helpful. Okay, and the second function is negative x squared minus 2kx. So for example, if I go to y2 and say negative x squared, sorry, I forgot x. So negative x squared, negative x squared. So minus 2kx. So we'll do minus 2, let's say k is 1. And we'll just do 2x. And that should be only when x is greater than 1. So x, remember second math, testing. So it's 3, 1, close the parentheses, graph. And now we'll see the second graph. Okay, but the second graph does not yet hit our graph, but we can visually see actually that, oh, it should be like about, 5 units down, or maybe 3 units down, so we can play with that. And if we play with different k's, and for example, if we're now smart and we do 2 times 4, okay, or we can just say right away 8 here, and now we graph. And now we see that they almost come together. Not exactly yet, but that's the best calculator can do for us. And that's also something we have to remember about calculators. They're not perfect. Okay, there are several, several pitfalls that we have to take into account. The lines that touch will not always exactly touch. And for example, we can't draw a function, a graph of the function with a hole. That doesn't work on the calculator. So there are always some natural restrictions that we have to keep in mind. But as you see, if we try here, we can use calculator, but obviously it's not at all necessary. And moreover, it takes huge time. So definitely we should not try using calculator here. Okay. but it was a good moment to learn something about calculator, since we want to do it today as well. Okay, let's do the second problem, and I put it on the second page. I will do it differently. I will put it on the same page so we can save a little bit of space. So this is our problem 76. And I will bring problem 77, since hopefully we'll be able to go faster. Okay, 77 is right here. So please welcome your thoughts on problem 77.
Does this mean that this problem is not solvable without a calculator?
Yes, you see, here we go into a problem which is not possible to solve without the calculator. Why so? Can you explain?
Because the antiderivative of e to the power of t squared does not exist, and it's not possible to integrate without using any either a calculator or a computer, so without using any software.
Yes. So basically, we need to find the integral here, right? So we need to find the integral from 0 to 2, right? Of e to the power of t squared minus 2 dt. And yes, in this case, look, this is also a very interesting thing. Yes, in this particular problem, and that's what usually happens in the calculator section, the function is not easily integratable, let's put it this way, right? But even if it is, we don't have to do it. Sometimes it would give you a function here. Yeah, you can take the integral manually, but you will require integration by parts or something like that, which you don't have time for.
No, but here it is probably not integrable at all, so it is an error function that one encounters in probability, but e to the power of t squared, impossible to express the integral through elementary functions at all.
That's what I'm trying to say, that in this particular case, it's not. But in general, I just expand this problem into a more general idea. Even when you do have a function that could be integrated more or less easily manually, in this section of the test, you do not have to do it. You do not have to spend time. And that's what students sometimes forget. That even if you see how to do it manually, you do not have to if it is faster by calculator, because your job here is to save time. In the first problem that we discussed, using calculator was a waste of time. Here, even trying to do manually, even if you see a function that would be possible to do manually, it's a waste of time to do it because you can go and do it straight on calculator. And I will show you how to do it on calculator. So a very important function of calculator is cleaning the screen, and it's a magic combination of sequence of keys, second plus 712, that actually clears all the data, all the inputs, because if you do not clear it and you do next problem, it may interfere with some previous data and give you either an error or a wrong answer. I always tell students before any new problem, unless you need the previous data for the new problem, clear the memory so that you start from the scratch. So now we go to math. And if we see function 9 here is fn int. Okay, so that's finding the numerical integral. So we can click 9, and we even see the whole format of the integral here. So we say 0, and we go up and we say 2. And now our function is e, and e has a special key here. So we do not use approximation of e in this case. We do not use like 2.7. Same way with pi. We do not use 3.14. We use a special key for pi, which has pre-installed approximation on the calculator. Then we go to the power, and in the power, we say, by default, it's x, and we don't worry about that, okay, because we don't care whether it's x or t, as long as here we put the same variable, okay? So integral from 0 to 2 of, oh, sorry, I forgot to put, it's e to the power of t squared minus 2. So we have to put minus 2. So I have to go back, and I have to click second del, which is insert minus 2. Okay, and now we're all set. So now we can click enter and get the response from the calculator, which actually corresponds to answer A, as we see, right? Does that make sense?
Yes. And by the way, there are a lot of ways. It's, well, it's not C, it's A.
So
Here.
A, yes. As I see, sorry. A, of course, yes.
Yeah, and there are like 3 ways to make an integral. Yeah, first of all, it's alpha f2, then 4. Yeah, second way it is what? It is math, then 9, and third
Yes.
way is second catalog. Well, this is a long way. Yeah.
Yeah, I usually teach the way through math because math has all the necessary functions there. So as long as you remember that math key has main library of functions that you may need, so I usually go through that one. But of course, if you know like other shortcuts and you are okay to remember them, you're absolutely welcome to do that. I usually try to like teach as fewer different paths as possible so that students know like where most of the things actually sit.
Mm-hmm.
But as I said, it's completely up to you. And thanks for showing multiple options. It's always to have a choice. It's always nice to have a choice. Okay, I can put our calculations here, so we can see. Sorry?
About I have one terminology question. The term distance. Does it mean the distance between start and end point? Isn't it the length of the path? I mean,
Mhm.
we have negative velocity in the beginning, and positive velocity in the end. So there are two different values, distance and the length of the path. In this case, we need to calculate the difference between start and end points, yeah?
That's actually a very good question. Let's try to look at it more carefully, because you may be right and we may be wrong at this point. Because distance traveled, yes, you're absolutely right. And by the way, because of that, we first need to look at the function. And yes, I violate my own rule that I always tell students to do. Whenever you find integral, you first need to look at what the function is. So I have to go to y and first graph e to the power of, I mean, they can see it from the formula, but graphing is actually more appropriate here. So if we look at this function, then we can see that actually it's not totally above the x-axis from 0 to 2. Okay, so it's actually below and above. So in order to actually do that, we have to split into 2 integrals. Right?
Mm-hmm.
So we have to actually do two integrals from 0 to 1 of negative e to the power of t squared minus 2, and then from 1 to 2 of the actual function, right? Is that correct?
The absolute value.
You can introduce
Yes.
the absolute value.
Or take the absolute value, yes. Or take the absolute value. You can do it that way as well. Okay, so let's go back to math 9. Okay, and let's now clear the screen. I mean, we can. Okay, we'll just do it from the beginning. So it's math 9, and we'll now do 0, 2, and then we have to do the absolute value here. Okay, so so we have to go to math and then numerical options, which is absolute value. So we have to open the absolute value, and now we do e to the power of t squared minus 2, and then we do dx, and then we hit enter. Yes, and then we get a different answer, which is answer B, which is actually the correct answer according to the answer key. Yes, that was a very good catch. So a very good catch. And I want to show you that the emulator actually has both function and table and graph, and it also shows you the history of the keys that you press. It's always easy to track down the keys that you need to press. Okay. Okay, are we clear on this problem? Shall we move on? Okay, let me replace the picture here so it's correct. It has absolute value. Yep. Okay, here we go. Make it a little bit bigger so that's more readable. Okay, so we take the absolute value of this. So of parentheses, put the absolute value, and then this is approximately 13. It's actually interesting that the calculator answer is slightly different. It's 638, not 368. So we'll take it as a typo of the problem. It happens because it's 13.368. Okay, and we'll choose answer B still, assuming that the digits are switched. Okay, good. Okay, let's move to the next problem. Let's move to the next problem. It will be problem 78. So you see the first two problems already give us a very good idea of what it means to use calculator and not to use calculator. So here's problem 78. Any thoughts about this problem?
I don't think the calculator is helpful here.
Okay.
For function f is not defined, so we do not know the exact formula for function f, and hence we only need to use properties of the integrals. So what happens if we swap the limits, the additivity of the integral as it is called, and that's all that is necessary here.
Does everyone agree with that?
Yes.
So what's the answer?
The answer is 1.
The answer is
Sorry, it's no. 1 sec. 2, 5. 7. Yes.
yes. The answer is 7. Okay, great. Yes, and again, this is where our calculator is not useful at all. Okay, this is where calculator is not useful at all. Okay, so D is our correct answer here, and let's move to the next problem. For next problem, we may need a separate page, so we'll go to the next page.
Unless if you don't remember some properties, then you can just take an arbitrary function and look what it does.
That's true too. And then you may want to use calculator. But again, we remember that multiple choice problems, on average in this section, we have a little bit less than 2 minutes per problem. Of course, we should try to be as efficient as possible. But if you get stuck and you did all the problems that you are fine with, and you come back to this problem to think a little bit more about that, that's definitely a good option to take some particular function and then use calculator and then play with that. Okay, here's the next problem. Here's the next problem. Any thoughts?
And concave up means that its graphs looks approximately this way.
It's concave up, decreasing, and positive for all real numbers. Right, so basically, if we want to be a little bit more precise with graphing it, so it's positive, so it's like we can say that it's right above the x-axis, and it means that we only talk about this part of it, right?
I just removed the unnecessary one.
Okay. Okay, yes, yeah, we did it at the same time. So which of the following could be false about f of x? So f of x is concave down for all x. F of x is increasing for all x. F of x is negative for all x, and f of x equals 0 for some x in the real numbers.
Well, f of x is negative for all x. I think not only it could be false, it is false. Yeah, because when we have an integral of this function from -2 to -3, it will be negative. It's just
So
because
what's our?
it's just because g of x is positive. And we know, do we know that we can choose only one letter? Yes.
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 So
That's a multiple choice. So it's only one.
We found C, and that's it.
And that's, by the way, that's a very also good point to note about multiple choice, because when we teach to this test, right, of course, we talk about content, but we also, of course, mention some test-taking strategies. And one of the strategies is remembering that, yes, out of these 4 options, only one is correct. And if you see one that is obviously correct, you just choose it and do not deal with others. I mean, there's always a temptation to check whether the other ones may also work, and maybe you've made a mistake or something, or maybe there's another option that works. No, it's only one option. And if you're 100% confident that you found an option that works, you can save time and not check the other 3. So that's also an advantage of multiple choice, I would say. Okay, so here the answer is C. That's correct.
But sorry, I have a question.
Yes.
So is it implied that x has to be greater than -2 or not? So nothing is told about the domain of function f, which makes this question a bit ambiguous to me. Or if we know, that the graph resembles like the one that is drawn here, let's assume that we say that the domain of f is when x belongs from -3 to -2. It seems possible according to the task, so I don't see any contradiction here. On the other hand, if choose a limit of integration, so if some value of a belongs to this interval, so the integral from -2 to a, g of x dx, it is equal to minus integral from a to -2, and the order of the points, the x-axis is this one, so a lies to the left of -2, and hence becomes negative. And furthermore, if the function is defined on the interval from -3 to 2, then it becomes negative for all the domain.
Yeah, but you see, the question of the problem is not which of the following is always false, but the question is which of the following could be false. So you give an example when it's not false, but Alexander gave an example where it is false. So it means that there are options when it is false.
So, then I don't understand. The last one could be false as well. F of x has to turn to 0. So it means that it turns... No, you see, without defining the domain of function, of the function, task doesn't seem to be correct. Is it implied that x belongs to all real numbers, or what? Or if I take the domain function, like x belongs from 3 to 4, then it is always positive on this domain. It never turns to 0. Or
that mentioning of for all x implies that for all real x.
Yeah, it says in D, it says is 0 for some
all
x
real
in the
numbers.
real numbers. Yes, yes.
Sorry, I haven't read the task properly. My fault. Yeah, okay. So
it's okay.
now
It's okay. No, that's perfect. Look, I can tell you that Theoretically, it's possible to have mistakes on the tests, even on the official ones. It happened. In my experience, though, the AP tests, AP math tests, the ones I dealt with, usually they're very well proofread, so it's usually not very easy to catch them on an obvious mistake, even though it doesn't mean it cannot happen. So absolutely feel free to doubt something and go through that and either resolve your doubt by yourself by reading it more carefully, or maybe saying that you look, yeah, this problem is and I know the cases, it very rarely happens, but I know cases when some students wrote in their solution booklets that, look, this problem is not clearly defined. There may be like several interpretations, and they got points for that because they were right. It, as I said, it happens very, very rarely with these tests. It happens much more often on SATs, for example, ACTs, also not very often, but definitely more often than on these AP tests. But it still does not mean it cannot ever happen. So yeah, so thank you very much for this note. Okay, let's move on. So as you see, that was another problem where calculator was not very useful. So again, we understand that if we have less than 2 minutes per problem, if each problem required a calculator, it would be impossible to do because sometimes it only takes like about a minute to enter everything into the calculator. So having each problem requiring calculator would not be feasible in this case, but some problems do. Okay, here's problem 80. We're on page 4. Any thoughts?
Well, here the calculator would be useful, I suppose.
I agree.
Just wonder if they mean it to find such a point X. So what's the rate of change or average rate of change on the interval? So what do they mean by that?
It's like delta y over delta x as the average rate of change.
I think that there is a typo here. It should be, is the average rate of change of f of x on 0, 4 is equal equal to the instantaneous rate of change of f of x.
Basically, they want the point where the instantaneous rate of change is the same as the average rate over the entire interval.
Yeah, but it's written like vice
what-
versa. Average rate of change.
For what value of x on this interval is the average rate of change? Oh, yeah, I guess there is a typo in the formulation. Yeah.
Let's see. What value of x and change. Wait, what do you think is a typo?
I think it should be the average rate of change of f of x on 0, 4 equal to the instantaneous rate of change of f of x, or instantaneous rate of change of f of x equal to the average rate of change of f of x on 0, 4. So on 0, 4 it should be...
No, that's possible too. I mean, what you say makes sense as well, but the question here is what value of x on the interval 0 to 4?
Mm-hmm.
Oh, wait a second. They have 0 to 4 there. Sorry, I thought they only have 0 to 4 once. What value of x on the interval 0 to 4 is the average rate of change of f of x equal to the instantaneous rate of change of... yeah, I see what they mean. They mean in general, on the closed interval, what value of x on the interval is the average rate of change. Yeah, I wouldn't call it a typo, it's just a poor wording. So it's not that they just... They meant to say what you say, but they just said it in a kind of clumsy way.
Mm-hmm.
Maybe if you just switch the average and instantaneous, like swap them, and then it will make more sense.
I think they meant to say that when talking about the instantaneous rate of change, they meant to say that point x has to be chosen from exactly this interval from 0 to 4.
Yes.
Might coincide with the instantaneous rate of change at some other point, for example, x equal to 10, and that's what they wanted to say. But as you told, they changed a clumsy way. They chose a clumsy way to say it. Yeah.
That sometimes happens. Yes. Okay. Anyway, are we clear with what to do here? Yes. So we have to find f prime, right? And yeah, so it's e to the cosine of 4 minus sine 4 minus e to the cosine of 0 over sine 4 over 4. Yeah, so that's the and to say that we're talking about, in terms of rate of change, we talk about 0 to 4 as a closed interval, but we're looking for the values of x on the open interval, not including the endpoints. That's what they tried to say here. Okay. So I see what's written, but can you clarify what we need to do to solve the problem?
Find the average rate of change first.
And how do we do that?
By finding the values at 0 and 4.
So basically what's written on the Jamboard right now is the average rate, right? Is the formula for the average rate.
That's the average rate, and to get the instantaneous rates, we just need to compute the derivative.
Oh, you wrote, okay, I see. That you wrote the condition that needs to be, okay, you kind of rewrote the problem. Okay, so basically, let's make it a little bit clearer. So Oops, sorry, I just.
Oh, okay.
Just one sec. I'm just trying to make it a little bit to bring it a little bit
Some
down
space.
so that
Okay.
no, don't erase anything. I'm working on the iPad so I can move things easily around. So just give me one
So
second.
can I? Okay.
If you do it on the if you do it on a computer, you cannot do it, but on iPad, you can. You have this function of actually moving things around.
By the way,
You move
how
it
to
down.
do it?
If you're on iPad, if you have Jamboard application on iPad, on the left in the menu there's an arrow to the left, like the kind of how to say
So
northwest arrow, and if you click on
yeah,
it,
I
you can
got it.
circle and move it around. Yes.
Got
So
it.
basically, yeah. Yeah. So that's only available on iPad. It's not available on the computer. So we're trying to say
But
that
I do it now on a computer.
how do you do that on the computer? No, you just move the picture.
You see that I move.
Yeah, but you just move the picture. Picture you can move on the computer, but the written text, no.
But I
You only move the picture.
okay.
Yes, but you can't circle written text and move a written text, and I can do it on the iPad.
Okay.
Okay. So we rephrase the question. So the formula you wrote is kind of rephrasing the question. So find x such that the average equals f prime of x, right?
We're meant to solve the equation to find the value of x using the calculator.
Yes.
Yeah, I guess it's not solvable. It's not possible to solve otherwise.
No, I mean, you can, the thing here is that there are two ways of doing this, maybe even more, but like there are several ways of doing that. So first thing you can do, you can actually put the left and the right side as separate functions. Okay, and so you can say y equals and graph them as separate functions. That's one thing. Okay, so you can say that this is what I mean to say. Yeah, you can put it as the horizontal line. I mean, probably the left hand side is easier just to calculate as a value. That probably will be faster. But just go and calculate it as a value. Right? So e to the power of cosine of 4. We need the parentheses in the beginning so that later we can divide the whole thing by 4. So parentheses e to the power of cosine of 4 minus sine of 4. Close the parentheses here. And then we get another parenthesis in the beginning, sorry, in the beginning. Okay, we need to insert the second parenthesis here. Okay, and then minus, open the parenthesis, e to the power of, well, cosine 0, we can say 1. minus sine of 0 is actually 0. And all that now needs to be divided by 4. Here's the value that we got, and we now need to find where our derivative of this of the function actually equals 4, right? And this we can do like this. We can go to y equals and say that y equals the derivative x. No, that won't work this way. Sorry.
Sorry, where you do you work now on in Jamboard or?
No, right now I'm on calculator.
Oh, and you don't demonstrate it.
Oh, sorry. I did not realize I didn't demonstrate it. Sorry. I thought you saw it. My apologies. Okay, let me bring it back. Okay, here we go.
Thank you. I can see it.
Sorry, I look at the comments in the chat with the delay. Yes, you're right. Most calculators have two different minuses. Yeah, the calculator does not show whether the endpoints belong or do not belong. That's one of the other drawbacks, because it cannot catch the exact point, because the calculator screen goes by pixels, and pixels are not as advanced. It does not show whether the endpoints belong or not belong. At least this model of calculator does not. So we found the value of the average, right? And now we need to find the derivative, right, of this function. And also, this model of a calculator cannot give you the formula for the derivative. The other model. Sorry?
Yeah, I wanted to ask, would it be faster to the derivative by hand and then substitute the values with the calculator?
That's one thing, or you can do graph of the derivative. It cannot give you the formula, but it can give you the graph. Okay, so you can graph the derivative on the calculator, and then using the table, match it with the value.
Just see which option is the closest, right? Okay.
Let me see. I thought you can still do it with this option, but okay, so dx, and then our function is e to the power of cosine x. minus sine x. It looks that you may be right. It's faster to take the derivative manually and just find the function, because in this case, the graph does not look very helpful. So,
Yeah, so it
so
just
it may be,
calculated the derivative at one point
yes. So I think it's yeah, it's not very helpful. So we can do, I mean, if I'm not wrong, I have to double check that. There is a way to graph the derivative as a function, not to get the formula, but to graph it. That's something I have to double check. I thought there was an option like that. But in this case, the derivative is pretty simple. It's negative sine, right? X times e to the power of cosine x. And then minus cosine x, right? Okay, so that's a derivative function, and that we can graph. Okay, so here's the graph. And we now can look at the table. And we need to find where it's, what, negative... Oh, wait. In this case, of course, we should do better. We do, sorry. In this case, we better graph. So we remember our value was what? Was negative 0.36. Okay, so in this case, we graph the second function, which is just negative 0.36 as a horizontal line. Okay. And we just find the intersection. Okay, so if we go to second trace, and that allows us to calculate the intersection. Okay. And then we have to, since we know our answers are, our options for the answers in this problem are from 0 to 2.5. So we can say find the intersection for the first curve, yes. The second curve, yes. And the guess should be around 1, so that you see there are many points, so it gives us the correct point. So let's say 1, and let's see what it gives us. Yeah, that gives us 1.9 approximately, which is the answer that we have as B. Because it has 1.90. Okay? Does that make sense?
Yes.
Mm-hmm. So the answer is B. So we got that this approximately equals negative 0.36. And then we said that f prime of x equals negative sine x e to the power of cosine x minus cosine x. Okay, and then using calculator, so this is our y1 on the calculator, and this is our y2 on the calculator. So using calculator, I will say intersection of y1 and y2. Okay, the answer is approximately x is approximately 1.90. So the answer is B. Okay. Are we good on that?
Yes.
Okay, how are we doing? We want to take another problem? We want to stop? What's the feeling?
1 sec. I think I've just found 1 sec. 1 sec. Oh, it seems like, well, sorry. Sorry, one more. I think I found a way to graph a derivative. Yes, I found a way to graph the derivative. So in you go to y equal to, you go
Yes.
and you have a derivative, and okay, derivative of some function. Yeah, so you just insert it as a usual derivative. Yeah, like math 8. Yeah, like okay.
Okay.
Uh,
Yes.
yeah, then you say x cube. Yeah, plus x. I don't know. Yeah, and the key is I'm happy that I found it. To say x is equal to x. Yeah, and there you go, and you graph.
Yeah, then you get the problem. Good. Yes, I knew there was a way to do that. I forgot how to do it. Either I forgot or maybe I did not know this exact trick. I just knew theoretically there is an option to graph the derivative. Yes, x equals x, sure. You see, these life hacks help a lot. Yep. Here we go.
Yeah.
So we could have graphed the derivative itself. And then just use a table. The only problem with this would be that let's try, actually, let's for the sake of interest, let's try to do it. So the function was e to the power of cosine x, right? So e
to
the power of cosine x. I'll tell you what I want to check. E to the power of cosine x minus sine x minus sine x. Okay, and then we hit graph. And here comes our graph. Yes, it's the same graph that we had before. Okay, and if we go to, now we basically want to find intersection with negative 0.36. So I'm just trying to figure out whether the chart will help us or whether we still have to do the horizontal line. because the table may not help us here. Just to catch where it is actually negative 0.36 might be by itself a pretty interesting task. If we go to second table, yeah, you see, here's the thing. We have to pick a step, which would be quite, so 0.1, for example, maybe. So second table set, if we do 0.1, and then look at the table. Yeah, now we might be a little bit luckier. Yeah, now we're a little bit luckier because we definitely see that it's around 1.9. But then still, we have two answers with 1.9 in the options. We have 1.901 or 1.966. So we actually have to.
Tap
It's more. What?
Could you do this? Could you set the step to 0.05, perhaps? And
I
then
can, yes, but then you understand we have to. Then we have to. Okay, we can do it this way. We can set it this way. We can do. I mean, first of all, it's pretty clear that we already have negative 0.361. That 1.90 is probably closer than 1.96, so we can guess it's B already. But we can also go to table set, and then we can say that the table start. No, we should start at 1 because, yeah, we don't have to start at 1 now. We can go to 1.9. So we can say start the table at 1.9 and go in 0.05 increments. And that might help us better. Let's see. Yeah, then it's definitely clear to 1.90, then 1.96. So, or we can even go by 0.01. The table said we start at 1.9. We can go by
at this point, just calculate the derivative at 1.901. See that it is.
Yeah.
See that it is negative 0.36.
Yeah, that's not a possibility. But we see, like, if we go by 0.01, we definitely see that by 1.96, we're too far away from negative 0.36. So it's definitely B. Yep, that's right. So as you see, when you're flexible with these things, you have more options. Okay, and you have to be flexible. That's why it's important to teach all these calculator things. Okay, so what do we do? Do we continue? Do we stop here? How do you feel?
I may continue as well. Let's hear other participants.
Yes.
Yeah, we can consider at least one more problem.
Okay. Let's do one more problem. Just 1 second. Okay, so next page, problem 81. Here we go. It's definitely a non-calculator problem.
Yes.
Mm-hmm. Any more thoughts, or are we done, or what? Where are we?
Well, it's d minus 1 over 4.
How do we know that?
Well, we have the formula here. So g prime of x is equal to 1 over f prime of g of x. And, well, basically we don't even need to worry about what is written here because, like, well, I mean, okay, we can really guess, but yeah.
We technically have a direct formula for the inverse, for the of the inverse.
Yeah.
So we can say right away that g prime at 3 equals 1 over f prime at g at 3.
Mm-hmm.
and g at 3 equals 1 because f at 1 equals 3, and obviously f and g are inverses of each other, right?
Yeah.
So f and g are the inverses, right, from this fact. And g at 3 equals 1, and then f prime at 1 equals -4, so it's -1/4.
Yeah, but I mean, if we don't have, if we have a restricted time, we can make it even shorter because, like, okay, so knowing this formula, we can say that it's, well, g prime is 1 over f prime at some point, and, well, from it's like very intuitively that the derivatives in different points do not, if we don't know anything about function, we can't control derivative in one point by derivative at other. So
Right.
we really will have only 1 over the derivative at the point that is given to us, no other way. So yeah,
That's true too. Yeah, that's a bit of legitimate cheating, let's put it this way. But yes, you're right. It has to be 1 over f prime, and if I don't remember f prime of what, I only have one value of f prime in the entire problem, and what else can it be? Then it's 1 over -4 right away. I tried to make it a little bit more clear, so to speak, mathematically, but you're right. In terms of test-taking strategies, absolutely fine. Yes. In terms of test-taking strategies, absolutely fine. If I need to divide by derivative of f at some point, and I'm only given it at one point, that's the one to use, because otherwise, what else? Okay, good. So you said one more problem. So are we stopping? Are we taking one more? What do people want to do?
yeah, maybe we can stop because I don't know.
Okay.
Yeah.
Okay, we can stop here. The next problem is actually totally visual, does not require calculator. It's what could be the graph of f prime. Okay, so let's stop here. The set is in the drive, so you're welcome to look at the rest of the problems. We did 1, 2, 3, 4, 5, 6 of them. There are 9 more. So you're welcome to do the rest of them, and if you have a calculator. And by the way, what I promised to give the app. Just give me 1 second, please. I will take literally 1 second to go grab something, and I'll show you interesting thing on the phone. Okay. Okay, so if you do not have calculator, you can download an app on the phone, which is, let me quickly check the name of the app because I always forget the exact name. Yeah, I guess this is the one. Yes. Okay, the app is called Calculate 84. I'll put it in the chat right now.
And I hope the
Calculate.
link to the Jamboard, like the Jamboard itself, won't be cleared, yeah, because we have some people that want to view the recorded.
No. Oh, moreover, I will save it as PDF.
Oh, okay.
And that's a possibility. I can, of course, leave the Jamboard open. The only thing, maybe, I don't know if I should open it for editing or just open it as for viewing.
I think for
But,
viewing is enough, yeah.
Yeah, and so I will lock it for editing now, and what? No, item only. they make things more and more complicated. Okay, so yes, and I will also send it as save it as a PDF file, and we can attach it to the files in our folder. So yeah, and I send the name of the app. So if you want, try it maybe like right now to see if it works, because that's the app that emulates calculator on your phone. So see if it opens, because usually it does, but
I see a lot of, I see graphing calculator plus 8483. That's it?
no, it should be exactly the name of the app.
Oh,
and it might also depend on the app store that you are in.
I'm on Android.
It is
Android, okay.
It's Calculate 84. There is a free version, but full version, it's not. It costs some money.
I think free version would be enough, because I at least have the version downloaded here, which I never paid for, and it should be more than enough. I mean, there are many of them. I just found that one was the most accurate, but you can try different ones, and you can even share with us if you found any that is better than this. To me, that was so far the closest to reality, because all others were slightly, I would say, I mean, they kind of try to do the same, but they're less close to the real calculator. This Calculate 84 is exactly the same as the calculator, but maybe there are other ones that can help with that.
I don't understand what I don't see in my.
It might be just the Apple app. I don't know, because I have it in the
And Sergey,
App
where
Store.
do you look for it? In Apple Store or in
Yeah,
Android?
In App
Apple.
Store. So it is called
Yeah.
Calculate 84. Yeah, exactly as he has written in the chat. I don't know if it's necessary. I could share the link to the Telegram chat, but I don't know if everybody needs it. There are too many people in Telegram chat, more that than really it's us here.
By the way, it's interesting thing that here we have that in Discord I see that we have a cap of 25 participants. Yeah, now we are not as popular, but yeah, but we have for this, for if we come close to this limit, we can use lesson. We discussed that option that you have some stage, so-called stage, where the presenters are situated, and also you have audience. And I hope that limit there for the number of participants is much bigger. Yeah.
There's another app you may try. It's called Calculator X. Put that one in the chat as well.
Or maybe it is time to buy an iPhone.
Calculator X. There's another app like this, which is also not bad. There's also an app which is also good, but you have to be able to see that, to understand that they call some functions slightly differently, but they're located in the same places. Calc 84.
So 84 seems to be some kind of a magic number.
Because that's the most common model of the TI calculators. 83 is a little bit outdated, but 84 is the most commonly used, because the later ones like 89 and Spire, they're much more elaborated and much more sophisticated, much more expensive. So TI 84 is probably the mostly used calculator for all models of 84. There's 84, 84 plus, 84 plus CE, but everything with TI with the number 84 is the most commonly used calculator, at least in the States. The second competing company is Casio, but they have, like, in my experience, Casio is less user-friendly. Plus, Casio calculators are more geared towards engineers, whereas TI is more geared towards education. Like, for instance, Casio, when you work with trigonometry, has 3 options for angles. It has degrees, it has radians, it has gradients. I wonder who even knows what gradient is.
I don't.
Yeah, that's a trick, and we actually bumped into that last week in school, because one of our students got the wrong answer on the test, and he claimed that he got it on calculator. So we tried both modes, degrees and radians, and none of the answers was like his. But he still kept claiming that he got it on calculator. So maybe he got some wrong mode, but he got it on calculator. And we had to actually look through all the calculators we have, and we found the Casio calculator that actually has a third mode, gradient. And I know gradient in theory. I never actually dealt with it in real life. Gradient is an angle measurement that was at some point introduced to kind of try to move angles into base 10 system. So gradient is 1/100th of 90 degrees.
Mm-hmm.
So that's why it's 1/400 of a circle.
Mm-hmm.
It's almost never used, but Casio has that mode, and that calculator was in that mode, and when we checked in that mode, the answer was exactly like the student gave us on the test. So we had to admit that that was not a content error, but that was a calculator error, which is completely different in terms of points that he lost. So we had to give him back some points.
Wow.
Yep. So that was a very interesting thing. And that's another thing. Another interesting thing with Casio is that, you know, these famous problems. Let me type it in the chat as well, which the whole internet raves about. This type of problems. Okay. So what's the answer to this problem? So what would you say the answer is?
It's either 36 or
36?
it's 1.
Okay, so, well, either or. I mean, what is it?
That's a game.
It's 36. Pretty sure.
Well, you see,
because,
let me tell you, for years, literally for years, I was kind of getting like absolutely mad when people said, "Oh, it's 1." I would say, "No way, it's 1." Okay, the order of operations, the division, multiplication are the operation of the same rank. We go left to right, 36/6, and then times 6, 36. Stop arguing, learn math, basically. Guess what? After many, many years of this, because these problems of this type come on the internet as an argument, I don't know, every few months with different numbers, they come across. So actually, it came in our competitors group. How it's called, like English, English for math or something like that.
Okay.
So they discussed that problem, and when I saw the discussion, I also kind of jumped at them, as I always do. And to their credit, for the first time ever, instead of presenting all these, loose arguments, oh, but this textbook has this. No, they actually presented a research, and I can send you a link if you're curious. Done by a young lady who, I think, as a student or as a young math teacher, she made a research. She actually researched real calculators. She actually researched real academia math papers, and she figured out an absolutely amazing thing, which I've never heard of, to be honest. I admit, even though it's embarrassing to admit, that the famous order of operation that we all use, which is in English called PEMDAS, right? Multiplication, exponents, parentheses, exponents, multiplication, division, addition, subtraction, has one modification that is absolutely widely used in academia / engineering math world, which has letter J, which stands for juxtaposition, which means that if a number is directly attached to the parentheses, it goes first. And according to that juxtaposition insert, this problem, 6 times 2 plus 4, would go first to get 36. And then you would do division 36 by 36 to get 1. And guess what? That's what Casio calculators give you when you have an answer like this, or when you have a problem like this. I couldn't believe my eyes. I took a physical Casio calculator, typed this problem into it, and I got the answer of 1.
Okay, I guess that makes sense because if there's no explicit multiplication,
Yes, it does, but it's all, you see, it's so much the matter of agreement, and it's never discussed at schools. On school level, you can kill me. I swear, on school level, there's no ever a conversation about this juxtaposition thing. But in academia papers, they use it all the time. And Casio calculator has it. I couldn't believe that TI and Casio, 2 different calculators, gave me 2 different answers to this problem. TI gives me 36, Casio gives me 1. So that's how I was convinced that it's actually an ambiguous problem, because before I thought, oh, what to argue about here? There's nothing to argue, just know the order of operations and stop wasting time. Turned out it was not that simple. So that's why TI is a much more commonly used calculator at schools, because it has a complete match with educational content and does not have all this engineering thing that Casio has, like gradient, juxtaposition, that no one in schools ever know about.
Yeah, but for me the problem, what I thought about here, why it could be 1, I thought that if you have a fraction like 36 or in a numerator and 6 times 2 plus 4 in denominator, you can write it like this, and maybe if the convention,
In TI you have to put another parenthesis around 6 times 2 times 4 to get 1.
Okay.
If you entered exactly like this I can show you. If you entered exactly like this on TI.
I tried it already. It's 36. Yeah.
Okay, guys. Sorry, I have to go now. So thank you for
this.
Thank you for joining.
Thank you, Sergey. See you later.
Thank you so much, everyone. If you have any questions or feedback, feel free. If not, we'll see you next time.
Yeah, maybe we can, as usual, discuss like an approximate plan for next time. I see. Maybe for next time, I hope that the guy Sergey Valkovsky will talk about A levels. Yeah.
Okay.
He will be ready.
Sure, why not? I mean, I'd be happy to, if I can, to join and listen, and if I have anything to add, I'll add. But he definitely, from what he says, he seems to be a better expert at A level. So definitely.
yeah, he works in, I suppose, yeah, at least he worked in London Gates. Yes, so
Mhm.
yeah, I think that he's
No, I taught A level as well, but for a very short time,
yeah,
so
yeah.
that's why definitely trust his experience more. So, and yeah, as I said, if I have anything to contribute, I'd be happy to, but
Yeah, yeah.
they can take a lead for sure. If he is ready to, definitely he can do it.
Very good. So see you next time.
Yes, thank you very
Thank
much.
you very much.
I thought,
Yeah, thanks for today.
Bye bye.
yeah, I hope it was interesting and educational
Yeah,
and
it was.
meaningful and fun.
Yeah, yeah.
Definitely interesting. Thanks.
Yeah,
Okay, great,
Bye.
great.
yeah, goodbye.
Goodbye.
Bye.